Hi, everyone. I'm very excited to be here to talk with everybody and to share the stage with Nico because we've been working together and researching for a few years now. So this is really exciting. Now, I want to talk to you about the history of open source first before we set up our whole presentation. So I'll start with a story. Once upon a time in the late 50s and early 60s on the campus of MIT, there was a club, and this was a special club for model railroad enthusiasts. Within this club, there was a special group of people, and they believed that things only had meaning if you knew how they worked. Now, this special group reveled in projects that were more than just building things. There were projects that were clever, innovative, and extraordinary. And in this club, this was where many students had their first opportunity to actually interact with the computer. And I say interact because computer technology was so new that many of the programs that we know now had not yet been developed. And this was the early days of computer science, where curiosity reigned, and many students from MIT and other American universities had become pivotal figures in the history of computer development. Now, I just want to say that the model railroad is really important because what's interesting is there wasn't computer engineering or computer science. These are people who are just interested in solving problems. And one of them is Eric Raymond. And he's an important figure in the open source movement. And from his book, The Cathedral and the Bazaar, he outlines 19 lessons. But these are a few that I find particularly interesting because these lessons, I think, epitomize the spirit of academia as well as computer development. It's about exploring one's curiosity with the help of like-minded people. To indulge our curiosities, we need to take risks by exploring ideas that are beyond our conventional methods. Now, Richard Stallman, the creator of GNU, he believed in sharing knowledge. And to do so, things like software should be free, like free speech, not like free beer, but that really does help. He helped found the Free Software Foundation, which promotes computer freedom. The acronym FOSS stands for Free and Open Source Software, and it promotes these 4 freedoms. Now, these freedoms ensure that the users of these programs would be free to create, imagine, and explore what interested them. Before the term open source came about, everything was free. That was just the way software was and was meant to be from the beginning. And when we talk about open source, we're talking about FOSS.
So yeah, so we have been very inspired about these pioneers and by these stories, but today we are here focusing about open source software for the AECO industry. So that's what we're going to do now. But how do you start talking about FOSS for the AECO? First, we need to analyze our relationship with software and digital tools. So that could be building information model. Building information model, which is a digital process that most AECO professionals are embracing right now, is being implemented everywhere, and something that started in the UK as a British standard to drive efficiency is being adopted now all over the world. So BIM is even a mandate in many countries now, which means that in many cases, BIM is not a choice or an option anymore, but more like a governing position. You must do it in order to participate in the public conversation. So this, in our opinion, shouldn't leave anyone indifferent. It's very important. BIM was originally conceived as a collaborative approach to lifecycle management, and the idea of it was to enhance communication, collaboration among the different groups connecting people and data for the industry. So we also think that only that way the industry could be truly benefited by this digital process. However, as we all know, we have experienced it, the way the industry is using BIM, it's different. It's mainly through proprietary software and closed file formats, which are, in our opinion, obstacles for collaboration and communication sometimes. So looking to Claudia's presentation about Open BIM, we know that Building Smart have described Open BIM as a BIM outside proprietary or closed file formats, and they describe Open BIM as something that permits interoperability, flexibility in the use of technology, vendor neutral, so no lock-in technologies. And what is really interesting is that, similar to what Julie was talking about when she was talking about calling open source something that was intended to be open from the beginning. In this case, Building Smart had to come out with a concept, Open BIM, for something that was also supposed to be open by default, which is BIM. It's something that already was supposed to be for collaboration and communication. So then we link this story with the pioneers. But why are we not using, why are we using proprietary software then, or we are mainly using proprietary software then? Because as we were hearing in the other presentation, it was the only way we knew. So the industry was and still is a little too dependent on proprietary solutions. So we heard from Greg and from Antonio about this. So we had a series of events for the last 3 years that have started to open the door to an alternative, to start thinking an alternative of proprietary solution. So yeah, so this was mentioned by Greg. October 2019, Dion Moulds, which is an architect and developer, releases Blender BIM. Okay, so the first time that we see a real alternative. There have been another examples, for example, FreeCAD and other, but here we start seeing a real alternative to proprietary solutions. Then February 2020, the OSARC group is created. So this is an online community that promotes that the built environment can be designed, constructed, operated, and recycled with free and open source software. Then then in July 2020, several leading UK and international AC firms wrote an open letter to Autodesk demanding changes related to cost, licensing, and business practices. And then here I put December, but Antonio said February 2021, the IFC.js library is released. So I'm not going to talk about the library because Antonio explained it really well. But basically, now we can start using the browser, which is a non-specific industry software to start using BIM. Then finally, 2 years after the first letter, in September 2022, the Nordic Architect Association published a follow-up letter for the first letter to Autodesk. And this letter was endorsed by architects of the Council of Europe. Thousands of architects belong to this group, and these events show us that many people wanted change, but we didn't know how to change. So yeah, we think letters have been very important and useful, but we as a sector need to take action in our own hands. So yeah, so Antonio just showed us with IFC.js what a strong open source community can do. And also the OSR community reconnect us with the spirit of the open source pioneers that Julie was mentioning earlier.
Yeah, so these events have really inspired us. And now we're convinced that open source is the way to go. In fact, at CIMS, we have multiple projects that are using open source tools and formats. And one of our most ambitious projects is one we've been developing for the past 3 years, and that's Imagining Canada's Digital Twin. Now, this is an exploration of the idea of a digital twin of Canada. What could a national digital twin of Canada be? What would it do? Who would it serve? And what would it look like? And what would it take to create it and to see it realized? Now, if you're not familiar with the term digital twin, it's a system that has 3 parts. So there's a physical thing in real space, a digital version of that thing in virtual space, and synchronized data connections between the two, updating the digital model to reflect its current state. Ideally, data would be uploaded and updated automatically using sensors or IoT to show us what's happening in real time, but it doesn't really matter the means. It depends on what the user case or use case is for the digital twin. Now, imagine a digital twin of the entire country. Britain has been developing a national digital twin, and that integrates their mandates for BIM level 2 submissions. And many cities are already working on digital representations, and they're calling them twins. But what is missing is a structure that can bring all of these urban representations together. So like Eric Raymond's lesson number 18, to solve an interesting problem, start by finding a problem that's interesting to you. So in March of 2020, we were fortunate to receive funding from the New Frontiers in Research Fund to develop this question further. This is a government funding program that supports high risk, high reward research. And our project, Imagining Canada's Digital Twin, or ICBT, is the exploration of a digital twin of Canada, high risk and high reward. Now, our research, we have 2 objectives: to build a research consortium of academic, Indigenous, not-for-profit, public, and private partners that represent local and regional networks. But we're also developing a prototype of the Montreal, Ottawa, Toronto corridor. So we're going to use what we've gathered from these 3 years, and we're going to apply for the next phase of the grant. And that's a transformation grant, which will provide funding for up to 7 years, and where we will take the idea of a digital twin and we'll explore it for all of Canada at a national scale and beyond the AECOO.
Yeah.
We've been researching all kinds of tools, including proprietary sources. We're not eliminating those. We've been researching game engines, and we understand that open source is the way to go. ICDT is the first national initiative to address the opportunities, challenges, responsibilities involved in developing a digital twin at a national scale in Canada. And by using open source tools and making Canada's digital twin easily accessible through a web browser, we want to encourage collaboration across industries Canada-wide to participate in co-creating a national digital twin. Now we'd like to present what we've developed so far with our prototype. So Nico is going to show you our open source collaboration platform.
Yeah, so this platform, as we were mentioning, is browser-based, so nobody will need a specialized software to access it. And then just like any device, or your phone, your tablet with any internet connection. And then you can, with this, navigate to anywhere in Canada. And we have noticed that there are a lot in municipalities and federal government, there are a lot of open data that is accessible online. But the problem is that they normally come in formats that are not really easy to access for our industry, JSON, GeoJSON formats, etc. So we want to find ways of easily make this data available and in a way that it can be integrated in our digital twin or BIM uses. And also this is a library that is OpenStreetMap that allow us to integrate the masses of the buildings of urban and rural areas. Now in Ottawa, we also want to make this platform more intuitive and also customizable. So you can change, for example, the style that you want your context to be in. And then we don't only want to integrate data coming from these libraries or from open data APIs or things like that, but we also want to allow users to take their models, for example, their IFCs, and upload them directly into the browser. So we have been using some of the tools that Antonio was showing, and here you can take, as I was saying, like your IFC, for example, here like the model of Downtown Tower. Pick a place in the context and load it there, so you are going to be able to see not only all of the geometry, but because this is BIM, you're also going to be able to import all of the metadata and work with it directly in the browser. So here you have, sorry.
Oh, I was just gonna say, and we're not limited to IFC. Like you can use GLTF, other open formats, but also we want to hear, what types of formats you use, or what do you need in this platform, and so you can visualize it.
Exactly. So BIM or models, but the idea is that we can put them together in a framework that can help you to integrate different layers. Here is a project, for example, that we have been working for the last 5 years, that is the digital campus of the entire Carleton University. And as you can see here, we have more than 50 IFCs of all of the buildings in Carleton, and we are able to load these 4 gigabytes of IFCs directly into our platform. You can visualize them in high quality, pan around them, and then maybe these models that before were archived in our servers are available for the community, for the students, for the staff, for the researchers to take a look. This is an isolated BIM viewer that we develop also with IFC.js tools that allows you to sort or filter by categories, change the perspective or the projection to perspective to orthographic, maybe to create plans and sections, etc. You can also cut 3D planes into any of the faces to go inside of the models to be able to see all of the assets that have been modeled in any of these IFCs. This example is the architecture building in the campus. So here you can see like all of the studios, the library, the pit, all of the stuff, and not only the geometry, but you can access all of the metadata and the entire tree of IFC that has been modeled directly in the browser. And as Antonio was mentioning, a browser is a really strong software. So we don't think that is limited, like way limited that desktop application. Here I'm going to show you, for example, Downtown Tower, the model that we just uploaded. more than 24 stories. It's a heavy model and we can visualize it there. And finally, how can an AC professional use this in a real case? So for example, here we are in this building, the building where we are right now. So here we can go and with the same tools, cut a section, take us directly to the room where we are right now. And then we can start communicating things about the space directly in our app. So you have your phone, you say, okay, we're gonna do an event right here. Let's see if we can bring the equipment through that door. So, okay, so we take the app, we measure directly on top of the digital assets. And then when you know that maybe the equipment is going to be able to be loaded there, you can communicate those things to the person that is bringing the equipment and just write that directly on top of the model.
We saw Nico log in at the beginning, and so we want every user to be in control of their data. So there will be levels, or how do we see security, and so that way you can permit what is public. But if this is one way where you could share it within organizations, so maybe not everybody gets access to VSIM, but hey, somebody who needs to make a delivery to Carleton, they need to access this, and so we can share it with them.
And these are some of the tools that we are developing because this is like a step by step. But let me show you some of the technologies that has enabled us to do this. As Antonio was saying, we don't need to start and create a wheel from scratch, but we have been using, okay, the technologies of the browser, JavaScript, CSS, and HTML, and then IFCJS, Mapbox, and MapLibre for the tiles, OpenStreetMap, and then to make this like a more maintainable and scalable platform, we are using TypeScript, React, and MongoDB for the database. So this means that we are taking these tools that Antonio was describing and Greg were describing, these tools that are available for us, and then we are combining them in a novel way to make something beautiful with them.
And we're not developers, and I don't think that the CIMS lab started as any type of, we're going to develop software, but this is what we've learned, as Antonio was saying, just by assembling and working together with a community of people who are interested, and they're producing these tools. Now, our goal is to explore new ways of using technology to disrupt conventional modes of thinking. There are challenges that the AECO that need to be addressed, and we believe through interdisciplinary collaboration, we can combine our strengths as individuals and work together to create something truly extraordinary. Now, a digital twin of Canada is a very complex system, and it's got different priorities and values than the ones that we've mentioned. We have yet to understand what it can be, which is why we're sharing our developments so far. Imagining Canada's digital twin requires discussion and collaboration, and it's a process that will involve many people. And in the spirit of the open source community, we need to work together to imagine and co-create Canada's digital twin. We want to allow access and enable underrepresented groups and SMEs who may not have access to proprietary tools to use this. And we also want them to help us understand their needs, and so we can create tools that will be relevant to them. And to do this, we need to find those groups that share this goal and work to move forward in this realization. Now, what kind of use scenarios can you imagine the digital twin of Canada? What kind of interface and tools would be useful for you, and what would you like to see?
And finally, maybe this is an open question that doesn't need to be answered today, but do you think an open source digital twin of Canada is even possible with the tools that we have been discussing? Would it be valuable for the industry and for underrepresented group to have access to a platform like this? And finally, would you like to join us? If you do, please reach out, and if you have any idea, comments about this project, we would appreciate it. Thank you so much.
Thank you.